We are starting now the solution of this paper 1 9709/12 for the mid-year 2024 for Beacon House. Question number 1 is find the coefficient of 1 over x in the expansion of 2x plus a over x square power 5 is 720. Find the possible values of a. Now, we can use the formula TR plus 1 is equal to NCR a power n minus r into b power r for the coefficient or the term for binomial expansion there. Since 2x is equal to a and a over x square is equal to b, then this formula will become TR plus 1 is equal to 5CR into 2x power 5 minus r into a over x square power r. This will become equivalent to 5CR 2 power 5 minus r x power 5 minus r a power r over x power 2r. It will be equal to 5CR into 2 power 5 minus r into a power r into x power 5 minus r minus 2r, because this is going to be shifted to the numerator there. This will be equal to 5CR 2 power 5 minus r into a power r into x power 5 minus 3r. Let's say that is the required coefficient of this binomial expansion there. Now, because we are acquiring 1 over x coefficient, so 1 over x, in other words, means x power minus 1, and the coefficient of 1 over x is given there 720, and this is the coefficient of all that 1 over x there. So 5 minus 3r should be equal to minus 1, or r should be equal to 2 there. So we put 2 into this equation number 2 there, and this will become 5c2 into 2 power 5 minus 2 is 3 into a is as it is power 2 there in equal to 720, because this will give you definitely x power minus 1 there. So 5c2 is 10 into 8 into a square is equal to 720, or a square is equal to 720 over 80, that is equal to 9, or a is equal to plus minus 3. These are the two possible values of a we are going to get in this part 1 there. Then we are going to start the second part of this question. Hence, find the coefficient of 1 over x7 in the expansion. So for 1 over x7 coefficient, that means x power minus 7. So if we compare it with the equation number 2 there, 5 minus 3r should be equal to minus 7, or 3r should be equal to 12, or r should be equal to 4 there. So we put r is equal to 4 in this equation number 2 there. So this will become 5c4 into 2 power 5 minus 4 is 1 into a power 4. So 5c4 as it is into 2, a is plus minus 3 power 4 there. So 5c4 is 5 into 2, 10 into this one is 81. So that is 810 is the coefficient of 1 over x power 7 there in this question. Now question number 2. In the diagram, ABC is a semicircle with the diameter AC, center O and radius 6 centimeter. The length of the arc AB is 15 centimeter and the point X lies on the AC such that BC is perpendicular to AX. Now, you are going to find out the perimeter of the shaded region BXC. So this is the semicircle shown there. This is the P point there. It is X, it is C, it is 90-degree angle. This is the shaded region for which we are going to find out the perimeter. This is O and this radius is 6. If we join O with B, this radius is also 6 centimeter. And the arc length of AB is 15 centimeter. And if this is angle theta there, we know that arc length is equal to r theta. For AB, it is 15, r is 6 into theta. So theta is equal to 15 by 6. So that is equal to 2.5 radians. Then if this is theta, let's say this is alpha, then theta plus alpha is equal to pi, or alpha is equal to pi minus theta, or this is 3.142 minus angle of this is 2.5. So this value will be equal to 0.642 radians. Now, we know that if it is a right angle triangle, BXO, where this is 6 centimeter, this angle is 0.642, then BX over 6 is equal to sine of 0.642, or Bx is equal to 6 into sine of 0.642. So that thing is equal to 3.592. centimeter. Then OX over 6 is equal to cos of 0.642. So OX is equal to 6 into cos of 0.642. So OX will be equal to 4.805. But we are going to calculate the perimeter of the shaded region where Bx is already calculated there. And now we will calculate XC. We know that OX plus XC is equal to 6. So XC will be equal to 6 minus OX. 6 minus OX value is 4.805. So that value is equal to 1.194. This is XC. And then the arc of this BC is equal to R into alpha there, where R is 6 and alpha there is 0.642. And that value is equal to 3.825. So shaded region is equal to the perimeter of the shaded region is equal to XC, which is equal to 1.XC plus BX plus arc BC. So XC is basically equal to 1.195. BX is equal to 3.592 and this is 3.852 and that value is equal to 8.635. So total perimeter is equal to 8.635 centimeter for this shaded region of this semicircle part. Now question number 3. The functions f and g are defined by f of x is equal to and g of x is equal to identify a sequence of the transformation which of the function y is equal to 1 over x is transformed to y is equal to f of x. and second part y is equal to x square is transformed into y is equal to g of x. Since in this question f of x is equal to 1 over x minus 2 plus 2, and we have given there y is equal to 1 over x there, and this will become now y over x minus 2. It means it is translated 2 units towards right on x-axis there. Then y2 is equal to 1 over x minus 2 plus 2. This means it is translated 2 units upward on y-axis for this. So these are the two properties which are going to be used in this part. At first, it is 2 units towards right is being translated, and then it is 2 units upward in this translation given there in the form of f of x there. Then we have g of x, which is equivalent to 3x square minus 6x plus 7. So let this complete it with a completing square, and then we will transfer these properties in this function. So g of x is equal to, if 3 is common, it should be x square minus 2x plus 7. This 3 as it is. Here we can use the completing square method. So x square minus 2x plus 1 square minus 1 square plus 7. This will become 3x minus 1 whole square minus 3 plus 7. This will become 3 into x minus 1 whole square plus 4, which is g of x there. So there are three properties used in this part. First, it is y is equal to x square. Now, y1 is equal to x minus 1 square. It means it is translated 1 unit on x-axis towards right of this. Then it is second, it is 3 times of this. Let's say y2, we write it as 3 times of x minus 1 square. So this is 3 there. So it is test 3 units on y-axis, because 3 units will be moved in the stretching on the y-axis there. And then this last is 3 into x minus 1 whole square plus 4. So that means plus 4 is what? So it is 4 units. It is moved or translated upward on y-axis there. So first it is translated on x-axis with 1 unit, that is stretched 3 times, and then it is 4 units, it is translated upward. So these are the transformations given in this function of this question number 2, for g of x is equal to 3x square minus 6x plus 7 there. Now, question number 4. The coordinates of the points A and B are -7 and 3 and 5 and 11 respectively. Show that the equation of the perpendicular bisector of AB is 3x plus 2y is equal to 11. A point is -7 and 3 and B point is 5, 11. You have to show that the perpendicular bisector of AB equation is given by 3x plus 2y is equal to 11. Now, we know that if this is the point A, this is the point B, this is the midpoint of this, which is perpendicular, because they are asking perpendicular bisector. So you are going to find out the equation of this line, which is supposed to be equivalent to 3x plus 2y is equal to 11. So first of all, we will calculate the midpoint of AB. That is equal to -7 plus 5 over 2 and 3 plus 11 over 2, which will be equal to -1 and 7. This is the midpoint of AB there. Then the gradient of AB, which is denoted by M there, and that thing is equal to 11 minus 3 over 5 plus 7, which is equal to 8 over 12, that is equal to 2 by 3. And the gradient of line perpendicular to AB is equal to minus 3 over 2, because it is the reciprocal of this portion there. Now they are asking the equation of this passing from this point -1 and 7 with the slope equal to -3 over 2. Then the equation of line will be y minus y1 is equal to m into x minus x1, which is equivalent to y minus y1 there is equal to 7. M there is -3 by 2 into x minus plus 1 there. So this will be equal to 2y minus 14 is equal to minus 3x minus 3, or 3x plus 2y is equal to 14 minus 3, or this equation will become 3x plus 2y is equal to 11, and that is the equation we have to show in the first part of this equation, that find the equation of the perpendicular bisector of AB is equal to 3x plus 2y is equal to 11. The B part. A circle is passing from this points A and B, and the center lies on this line (12x minus 5y is equal to 70). Find the equation of the circle there. So for this B part, it is passing from this 12x minus 5y is equal to 70. This is the given equation for this portion there. Let's say this is the circle. It is the point A and B. This is the center C, and it lies on this line, which is equal to 12x minus 5y is equal to 70. And you are going to find out the equation of this circle passing from this. So that means what? First, we are going to calculate the radius there, and then you are going to calculate the coordinates of C there. So this is the line which is perpendicular bisector of this portion. So it means this line and this line are going to meet at the point C, and the equation of this perpendicular bisector is already given to you equal to 3x plus 2y is equal to 11. Let's say it is equation number 2. So C is the point of intersection of these two lines there. So first of all, we will find the coordinates of C. So it should be equal to, if we multiply this by 4, it is 12x plus 8y is equal to 44. And the equation number 1 is already there. 12x minus 5y is equal to 70. Now we simplify these two. Negative, positive, negative. So this and this they are going to cancel. So this is 13y is equal to minus 26, or y is equal to minus 2. Then x value we can put it in any one equation. 3x plus 2y is equal to 11. 3x plus 2 into minus 2 is equal to 11. 3x is equal to 15, or x is equal to 5. So the center C has this equation 5 and minus 2 there. Then the radius, which is equal to r, and that is being calculated as, you can use A and C there. So that is A coordinates are there, minus 7 and 3, and C coordinates we have just calculated it equal to 5 and minus 2. So the radius will be equal to minus 7 minus 5 minus 12 square plus minus 2 minus 3 minus 5 square and whole square root. So it should be equal to 144 plus 25, that is equal to 169 square root, that is equal to 13. So the equation of circle will be x minus 5 whole square plus y plus 2 whole square should be equal to 13 square. This is the required equation of the circle, which is being calculated from these two parts of this solution there. Now question number 5. The function g is defined by g of x is equal to 2x square minus 6x plus 5 for x lies between 0 to 4. Express g of x in the form of a into x plus b whole square plus c, where a, b, c are constants. Now, we are going to use the completing square method for this portion. because this is going to be converted to the form of a into x plus b whole square plus c, and you have to give the values of a, b, c there. So g of x is equal to 2, take it common if it is not 1, it should be x square minus 3x plus 5. It should be equal to 2 into, it is completing square method is x square minus 2 into x into 3 over 2 plus 3 over 2 square minus 3 over 2 square plus 5. So this will become 2 into, it is up till here, it is x minus 3 over 2 whole square minus 9 by 4 plus 5. This will be equal to 2 into x minus 3 by 2 whole square minus 9 over 2 plus 5. This will be equal to 2 into x minus 3 by 2 whole square plus half. So if we compare 1 and 2, then a value is equal to 2, b value is equal to minus 3 over 2, and c value is equal to half. Find the range of g. Also, the function h of x is defined by h of x is equal to 2x square minus 6x plus 5 for x greater than or equal to k less than or equal to 4, where k is a constant. Describe the smallest value of k for which it has the inverse there. So you are finding the second part, range of g of x to this portion there. If we draw the sketch of this, so because coefficient is positive, so it will be minima, vertex is at 3 by 2, and your y-intercept is at half there. So it's cutting at the half, not y-intercept. Y-intercept is basically equal to 5 there. So the range of this graph will be from this, because they are saying from x equal to 0 till 4, that is g of x. So for 0 value, it is half there. And more than equal to half. And again, g of x, if you put 4 into this, then it is equal to 2 into 4 square minus 6 into 4 plus 5. So that thing is equal to 32 minus 24 plus 5, 30. So the range of this graph, g of x, is more than equal to half, less than equal to 13 is the answer of this question there. Because it is lowest value is there half and the highest value there is 13. And then the last part of this, h of x is equal to 2x square minus 6x plus 5 and you have to show the smallest value of this portion is there. And the smallest value is occurring at this turning point. So k is less than equal to x less than equal to 4. So k value is equal to 3 over 2 there, because it is the turning point of this graph there. Now, find the inverse of h of x there. Since h of x is equal to 2x square minus 6x plus 5, and which is being written in the form of 2 into x minus 3 by 2 whole square plus half, that is equal to h of x. And you are finding now h inverse of x for this expression there. So we can suppose let y is equal to h of x, then x is equal to h inverse of y. So you are going to make x as a subject from this equation there. So let's say y equal to 2 into x minus 3 by 2 whole square plus half. So first of all, y will be equal to y minus half is equal to 2 into x minus 3 by 2 whole square. So that is 2y minus 1 over 2 is equal to 2 into x minus 3 by 2 whole square, or 2y minus 1 over 4 is equal to x minus 3 by 2 whole square. By taking the square root on both sides, this will be plus minus 2y minus 1, 4 square root is 2, equal to x minus 3 by 2, or x is equal to 3 by 2 plus minus 2y minus 1 square root over 2, or this will be x is equal to 3 plus minus 2y minus 1 over 2, but x itself equal to h inverse of y. So h inverse of y is equal to 3 plus minus 2y minus 1 over 2. So h inverse of y will be replaced by x. So that should be equal to 3 plus minus 2x minus 1 over 2. But because it should be, the vertex is lying at 3 by 2. So, and it is, the range is given there from 0 to 4. So h of inverse of x will be equal to 3 plus 2x minus 1 over 2. We will ignore the negative sign because it is before the turning point of this ball. And the vertex inverse only lies either after the turning point or before the turning point. Since it is after the turning point, so it should be plus there. So that is why we have written it h inverse of x is equal to 3 plus 2x minus 1 over 2 there. Question number 6 now. This is the graph shown there, y is equal to a plus b sine of x. Find the values of the constants a and b there. Since this graph is cutting the y-axis, sorry, x-axis like this, and this is the y-axis, so it is cutting the y-axis at -2. So a value is equal to -2. And then y equal to a plus b sine of x, where y value is equal to 1 and a value is there equal to -2 plus b, and sine of x value is there pi by 2 because it is going to be shown it there 1 there. So that is equal to 1 minus 2 plus b into 1. So b value is equal to 3. So there are two values, a is -2 and b is equal to 3 for this question. F of x is equal to a plus b sine of x there. B part. Show that the equation sine theta plus 2 cos theta into 1 plus sine theta minus cos theta is equal to sine theta into 1 plus cos theta can be expressed in the form of 3 cos square theta minus 2 cos theta minus 1. So our original question is B part. Sine theta plus 2 cos theta into 1 plus sine theta minus cos theta is equal to sine theta into 1 plus cos theta. And you have to express this form in this 3 cos square theta minus 2 cos theta minus 1. You have to show this part. Now, let's take this B part. Multiplication, simple. So it should be equal to sine theta plus sine square theta minus cos theta into sine theta plus 2 cos theta minus 2 sine theta cos theta plus minus 2 cos square theta is equal to sine theta plus sine theta cos theta there. So here sine theta and sine theta, that is going to cancel. This is minus sine theta plus 2 sine theta. It is sine theta cos theta plus, so that is going to cancel. So finally it is left there sine square theta minus 2 cos plus 2 cos theta minus 2 cos square theta equal to 0. But sine square theta itself equal to 1 minus sine square theta plus 2 cos theta minus 2 cos square theta is equal to 0. This sine, sorry, 1 minus cos square theta. So this minus this, so minus 3 cos square theta plus 2 cos theta minus plus 1 equal to 0. Or if we shifted the signs, this will be 3 cos theta minus 2 cos theta minus 1 equal to 0. And this is the thing we have to prove in this part there. Then they are asking hence solve this equation from minus 180 to plus 180. So since this expression is equal to this expression, so we are going to solve this C part. So it should be equal to 3 cos theta minus 2 cos theta minus 1 equal to 0. Let cos of theta is equal to k, then cos square theta is equal to k square. So this will become 3k square minus 2k minus 1 equal to 0. Let us solve it. 3k square minus 3k plus k minus 1 should be equal to 0. 3k is common, so it should be k minus 1 plus 1 is common. It should be k minus 1 equal to 0, or k minus 1 into 3k plus 1 equal to 0. So k value is equal to 1, or it is equal to minus 1 by 3. But k value itself equal to cos theta, which is equal to 1. So theta is equal to cos inverse of 1, that is 0 degree, or (360). But 360 is not in the range, so here should be only one angle there, that is 0 degree there. Then for the other values, cos of theta is equal to k, that is equal to minus 1 over 3. So minus indicates that if it is ASTC, then cos is negative in the second and the third quadrant. So let cos of theta is equal to 1 over 3, then theta is equal to cos inverse of 1 over 3. So it is 70.5 degrees. But cos is negative in the second and third. So second quadrant will say 180 minus 70.5, and third is 180 plus 70.5. So this will become equivalent to 109.5. So this angle is more than 180 because our range is given there from minus 180 to 180. So this angle will be subtracted from 360. So total angles will be equal to 109.5 and minus 109.5. So there are three angles. So theta is equal to 0 degree, or 109.5 and minus 1 over 9.5. These are the calculations for this angle theta there for this question number part C. Now question number 7. In an arithmetic progression is such that the 10th term of the first term is 6 and the 10th term is 19.5. Find the sum of the first 100 terms in the arithmetic progression. The first term is 6 and the 10th term is 19.5. You are going to find out the sum of the first 100 terms. So in this case, we know that in arithmetic progression, an plus n minus 1 into d is the term there. So the 10th term is there 100. So we can write this a10 is equal to a plus 90. 10th term is 19.5. A is there 6 into 9d. So d should be equal to 19.6 minus 6 over 9. So d is equal to 1.5. Then the sum of the first 100 terms is equal to n over 2 a plus l. So n is there 100 over 2, a is there 6 plus the last term there is an. That is the 10th term, which is equal to 19.6. So that value is equal to n over 2, 2a plus n minus 1 into d. So it should be equal to 100 over 2, 2 into a is 6 plus 99 into 1.5, and that value is equal to 8025. Is the answer for the first 100 terms of this progression there. The B part. A geometric progression has A1, A2, A3 is so on that A1 is equal to 24 and the common ratio is half. The sum to infinity of this progression is denoted by S. The sum of the infinity of the eventh number term is A2, A4, A6 is denoted by SE. Find the value of S and SE. Since we know that the geometric progression has the first term a, then ar, then ar square, then ar cube, and so on. Sum to infinity is denoted by a over 1 minus r, where r modulus is less than 1, where a is 24, 1 minus half, and that is equal to 24 into 2, and that is equal to 48, is the sum to infinity of this function. But the even term a2, that is equal to ar, so that is equal to 24 into half, that is equal to 12, a4, that is ar cube. So a is 12, r is 1 by 2 power 3, so that is equal to 12 by 8. It should be equal to 24 by 8, that is equal to 3. Then a6 is equal to ar5, a is 24 into 1 over 2 power 5, and that value is equal to 3 by 4. So now we have 12, 3, 3 by 4 for the even term of this. So sum to even term is equal to a over 1 minus r. A is there 12, 1 minus r is basically equal to 3 by 12, that is equal to 1 by 4. So that is equal to 12 over 4 minus 3 by 4, or 12 into 4 over 3. So that is equal to 16. So sum of even term is equal to 16, and sum of the whole terms is equal to infinity is equal to 148. Question number 8 now. The equation of this curve y is equal to 2x square minus 1 over 2x plus 3. Find the coordinates of the stationary point. Since this equation is given to you, and for the stationary points, we know that we have to get dy by dx and put dy by dx equal to 0 to get the value or values of x there. And then this is given to give you in the y, that will give you the total stationary point for x and y there. So y is equal to 2x square plus 1 over 2 x power minus 1 plus 3. So dy by dx is equal to 4x plus half into minus 1 x power minus 2 plus 3 equal to 0. So that is equal to 4x minus 1 over 2 x square, that is dy by dx. Now we put dy by dx equal to 0. So 4x minus 1 over 2x square equal to 0, or 4x is equal to 1 over 2x square. This will become 8x cube equal to 1. Or x cube is equal to 1 over 8, or x is equal to 1 over 2. it is minus there. Sorry, it's minus. It should be equal to plus, then this minus. So 8x cube is equal to minus 1 over 8. So x value is equal to minus 1 over 2. Then y value will be equal to 2 into minus 1 over 2 square minus 1 over 2 into 1 over 2 plus 3. So that is equal to 2 over 4 minus 1 plus 3. So that is 1 over 2 minus 1 plus 3. So y value is equal to 9 by 2 there. So the stationary point there is minus 1 over 2 and 9 over 2 is the answer of this stationary points to this curve there. Determine the nature of this stationary point. So nature means that you are going to do the second derivative of this portion there. So this will become B part, the nature. And for the nature, you find the second derivative of this curve there. So our first derivative is equal to 4x plus 1 over 2x square, which you can write this thing as 4x plus 1 over 2 x power minus 2. That is the first derivative. Now we have to find out the second derivative. 4x, its derivative is 4 plus half minus 2 into x power minus 3. This will become 4 minus 1 over x cube is the second derivative of that. Since x value is minus half, so 4 minus 1 over minus 1 cube, that is equal to 4 minus 1 over 8, that is equal to 4 plus 8, so that is equal to 12, which is greater than 0. So it is minimum at this point there. So that is the nature of this point. For the value of x, which is equal to minus half there. Question number 9. A curve has an equation y is equal to 3 over 2x square minus 5. Find out the equation of the normal to this curve at the point 2 and 1. Of this in the form of ax plus by plus c is equal to 0, where a, b, c are integers. Since this can be written as y equal to 3 into 2x square minus 5 power 1 minus 1. So dy by dx are m, that is equal to 3 into minus 1 2x square minus 5 power minus 2 into the derivative of this function itself only. So 2x square derivative is 4x minus 0. So that is going to be equivalent to 4x into this. So minus 12x over 2x square minus 5 whole power 2. That is the value of m there. But they are asking the equation of the normal at this point 2 and 1. So x is equal to 2. So m is equal to minus 12 into 2 over 2 into 2 square minus 5 whole square. So that thing is equal to minus 24 over 4 to the 8 minus 5, 3 is 9. So that is equal to minus 8 over 3. That is the gradient of this curve there at the point 2 and 1. So required gradient, because you are finding the normal, that is equal to 3 over 8. So the equation of the normal to this curve is y minus y1 is equal to m into x minus x1. So y minus 1 is equal to 3 by 8 into x minus 2, or it should be equal to 8y minus 8 is equal to 3x minus 6, or minus 3x plus 8y minus 8 plus 6 equal to 0, or it should be equal to minus 3x plus 8y minus 2 is equal to 0. Or you can even write this thing as 3x minus 8y plus 2 equals 0. So any one of this equation is in the form of ax plus by plus c is equal to 0. Find the set of the values of m for which the line of this equation y is equal to mx plus 1 and the curve has the equation y is equal to 3x square plus 2x plus 4 intersects at 2 points. Since we have the equation of the line there is equal to and this curve has an equation there equal to y is equal to mx plus 1 and this curve has an equation 3x square plus 2x plus 4, and they are saying that it is cutting at 2 points, that this is a curve and this is a 2 points. So that means what, p square minus 4ac should be greater than 0. So first they are both equal to y, so we can equate that 3x square plus 2x plus 4 is equal to mx plus 1. This will be written as 3x square plus 2x minus mx plus 4 minus 1 is 3 equal to 0. This is 3x square plus 2 minus m into x plus 3 equal to 0. This is the value of a, this is the value of b, and this is the value of c. Because it is cutting at 2 points, so b square minus 4ac should be greater than 0. b there is 2 minus m whole square minus 4 into 3 into 3, that is greater than 0, or 2 minus m whole square minus 36 is greater than 0, or 2 minus m whole square is greater than 36. Just we are going to find out the critical solution. So 2 minus m whole square is equal to 36, or 2 minus m is equal to plus minus 6. 2 minus m is equal to 6, or 2 minus m is equal to minus 6. So m should be equal to 6, 2 minus 6, 4, and m should be equal to 6 plus 2, 8. Since it is a quadratic equation, if we open it, 2 minus m whole square is equal to 36, it will become 4 plus m square minus 4m minus 36 equal to 0, or m square minus 4m minus 32 equal to 0. It should be equal to m plus 4 into m minus 8 is equal to 0. So m should be equal to minus 4 and 8. Since the coefficient of m square is positive, so it will be minimum, and we have to show that it is greater than 0. So either it will be before minus 4 or it is after 8. So the required answer is m should be less than minus 4, or m should be greater than 8 for the values of this curve, which is going to cut at the 2 points there. Question number 11 now. The functions of f and g are defined by x belongs to the real number, where f of x is equal to half x minus a, and g of x is equal to 3x plus b. Where in both cases x belong to the real numbers, where a and b are constants. Given that part A, g of 2 is equal to 10, find, and f inverse of 2 is equal to 14. Find the values of a and b there. So we know that g of 2. So first point, g of 2, that is equal to g as it is. G of 2 is equal to 3 into 2 plus b, or that thing is equal to g of 6 plus b. So that thing is equal to 3 into 6 plus b plus b. So that thing is equal to 18 plus 3b plus b, or that is equal to 18 plus 4b, and that value is given equal to 10. So 18 plus 4b is equal to 10. So 4b is equal to minus 8, or b is equal to minus 2. Then they are asking g f inverse of 2 is equal to 14. Since f inverse of 2 is equal to 14, so 2 should be equal to f of 14 there. So f of 14 will be equal to half into x is 14 minus a, and that should be equal to 2 there. So 7 minus a is equal to 2, or a is equal to 7 minus 2, and that is equal to 5. Using the above values of a and b, find an expression of g f of x in the form of cx plus d, where c and d are constants. Since b is minus 2 and a is equal to 5, so f of x is equal to half into x minus 5, and g of x equal to 3x minus 2. And you are finding now g f of x. So this is g as it is. F of x is basically equal to half x minus 5. So this will become equal to 3 into half x minus 5 minus 2. This should be equal to 3 by 2x minus 15 minus 2. This thing is equal to 3 by 2x minus 17. So g f of x is equal to 3 over 2x minus 17. That is equal to cx plus d. So c value is equal to 3 over 2 and d value is equal to minus 17. So this is the last part of this question number 11. So we have solved each and every question of this paper 1 of this 2024.